Hi students, today we will discuss one important concept, that is angular momentum. Compulsory question in JEE mains and NEET no, even advanced no, mostly they will ask the questions based on this one. No. Angular momentum is nothing but a moment of momentum, that is in translator motion. So momentum is there, we already defined how much amount of motion is there, we already calculated. So linear momentum is nothing but a mass into velocity. Here angular momentum means what? So if an object is rotating, therefore how much amount of rotational momentum it is there, that is moment of momentum. How to calculate now? The same. So linear momentum which is there no, we already studied, L is equals to so mass into velocity. So similarly here angular momentum is there no, so angular momentum here no, linear momentum is denoted as P. So angular momentum is denoted as, so instead of this mass here moment of inertia, instead of this velocity, angular velocity now. Clear? So in this way we can define angular momentum, right? So comparing for linear momentum and angular momentum. So we can calculate angular momentum in another way also, that is we can define if any object is going. So therefore here, suppose here we can define it no, suppose if any object, therefore here if a particle it is there no, it is having mass m, so therefore it is moving with a velocity no, therefore it is having momentum. Yes or no? What is the momentum here now? Therefore mv. So therefore we can define that moment of momentum no, so that is momentum into perpendicular distance. So that means, so here with respect to the origin no, with respect to the origin, or we can take it as like a perpendicular distance no. So angular momentum can be defined as, angular momentum is defined as momentum into perpendicular distance, or distance into perpendicular momentum also we can rewrite it down. So therefore L is equals to, this is mv into perpendicular distance is, that is r. So in terms of vectors no, we can rewrite it as, that is L is equals to, so r cross p, we can rewrite the angular momentum now. Angular momentum is a vector quantity. So like momentum is a vector quantity, it's linear velocity direction no. Angular momentum, therefore it is having the, it is an axial vector now. Therefore here it is an axial vector. That means it is acting along the axis. Angular momentum no. Therefore what will be the unit of this one now? What is the unit? So here moment of inertia. What is the moment of inertia now? SI unit now. What is the SI unit? SI unit is nothing but a kg into, so meter square into radians per second, therefore by second now. Therefore so SI unit of your angular momentum is, so kg meter square by second now. So what will be the dimensional formula here now? Dimensional formula, so kg is nothing but m1 L2 t minus 1. So this it will be your dimensional formula now, right? So we know, therefore angular momentum is a vector quantity no. So we can calculate angular momentum, direction of your angular momentum by using right hand thumb rule now. The direction of your angular momentum no. So here momentum is there, here it will be your distance no, therefore here r vector, here momentum vector is there no, that is nothing but mv. So you have to use right hand thumb rule, therefore right hand thumb rule no. So this is r, therefore 2p, therefore r cross p, therefore it is into the board no, therefore into the board, therefore this it will be your angular momentum direction no. In this way we can calculate angular momentum, the direction no. So the angular momentum is perpendicular to the linear momentum and perpendicular to the position vector also. Let us see, we can rewrite it now. So angular momentum is defined as how much no, how it will be? So therefore r cross p, therefore here you can rewrite it as L is perpendicular to r, that means L dot r also we can write it no, this is 0. So L is perpendicular to p, therefore L dot p, so dot product is also equal to 0. In this way we can calculate it no. So L is equals to, therefore that is you can write down, this is mv, m into r cross v. So still you can write down m into v into r into sin theta. Clear? So when will be the angular momentum will be maximum here now? So we can rewrite it as angular momentum. So here angular momentum will be maximum. So when theta is equals to 90 degree, that means sin 90. So sin 90 is equals to 1. So angular momentum is maximum is nothing but m into v into r. So angular momentum will be 0. Angular momentum will be 0. So that is here velocity is 0. It is not having any momentum. It is not moving. No. So therefore velocity will be 0. Also angular momentum will be 0. Or if theta is equals to 0 or 180. That means if an object is going along the axis of rotation, no. So therefore does not have any angular momentum, no. Therefore why? Because sin 0 is 0. So therefore angular momentum will be minimum. So if a particle is going along the axis of rotation, no, or opposite to the axis of rotation, no, angular momentum will be 0. Angular momentum will be maximum when a particle is going perpendicular to the axis of rotation onto this. Clear? So we can calculate the formulas, or we can calculate the problems by using angular momentum. How? Therefore angular momentum can be written as r cross p. Therefore angular momentum can be written as like a I into omega, right. So we can calculate here torque, no. Therefore we know that force is equals, what is the force formula? Force is equals to rate of change in momentum. Similarly here force make an object to move in a linear motion, no. So torque make an object, no, make it to revolve. Therefore torque can also be defined as, that is nothing but a change in angular momentum by time. Therefore final angular momentum minus initial angular momentum by time. So therefore if external torque acting on the system is 0, that means there is no external torque. If there is no external torque acting on the system, so therefore what will happen now? Total initial angular momentum will be equal to total final angular momentum. So this is nothing but a law of conservation of angular momentum. Right. So we will see lot of examples onto this, no? Law of conservation of angular momentum, initial angular momentum, final angular momentum. So what is angular momentum formula? Therefore here I1 omega 1 is equals to I2 omega 2. So therefore omega is inversely proportional to the I. That means if we are able to change the moment of inertia, therefore automatically angular velocity will be changes onto this, right. If moment of inertia is increased, angular velocity is decreased. If moment of inertia decreased, angular velocity will be increased, right. So we will see one best example for this one, no. One best example. So conservation of angular momentum, no. Suppose you might have we can do some simple experiment, no. What are the simple experiments now? Let us say there is a one turntable is there. This is one turntable. That table is rotating now, rotating chair. So therefore upon to this one now, there is one person is there. He is stretching his hands, no, and standing on to this one now. Therefore this table is rotating. This table is rotating with an angular velocity is omega. So when a person is stretching his hands like this, so he is having moment of inertia is I. Now therefore once he started rotating, therefore while standing onto this one, no, he is rotating with an angular momentum. If he closes his hands like this, no, so you will see that when he closes his hands, what happened to the moment of inertia? See, when mass is distributed like this, so moment of inertia is increased. But when he closes his hands, no, moment of inertia will be decreased. Why? Because mass is distributed near to the axis of rotation now, right. So mass is distributed near to the axis of rotation now. Therefore when he folds his hands, no, so when folds his hands, no, so what will happen now? Moment of inertia will be decreased. So therefore when he folds his hands, no, what will happen now? Moment of inertia will be decreased. When moment of inertia decreased, you will be observing that therefore this person will be rotating with a greater angular velocity. That means angular velocity will be increased. That means he will be rotating very, very faster now, right. So why he is rotating faster now? Because he is changing his moment of inertia. Therefore here it is, so it lead to the conservation of angular momentum. That's why his angular velocity is increased. Similarly You might have seen in the now like a diving, therefore most of the people they will in the Olympic games, what they will do, they will jump, right? So like a swimmer is there, they will jump it, right? So when he jump, therefore when he is in this air, so what he will do, he will fold his hands like this. So he will fold his hands and legs, so when he folds his hands and legs, what will happen now? His moment of inertia was decreased because all the particles came closer. So moment of inertia is decreased. So angular velocity, what will happen now? Increase. Therefore, he will be doing more number of rotations in the air. So therefore, now before landing onto this one, what he will do? Again, he will stretch his hands and therefore like this, so that here moment of inertia is increased, angular velocity will be decreased. So therefore, he will be able to land very easily. So he has to do more number of rotations in the air itself. So that's why what he will do, he will fold his hands and legs very closer, so that he will be able to do more number of rotations in the air, right? So this also one of the example for our conservation of angular momentum now. Clear? So even we can have one more example also. So therefore this is our sun, and all the planets, therefore all the planets are revolving in the elliptical orbits. Suppose if the planet is at this point, if the planet is at this point and at this point, therefore at this point, therefore when the planet is at this point, therefore at this point the speed it will be, so speed it will be very low, therefore the speed will be less. Why? Because distance is more here. So why? Angular momentum, initial angular momentum, final angular momentum. You can write down mvr, m1 v1. So therefore m into v2 into r2. Therefore you can write it now. Therefore v is inversely proportional to the distance. That means if distance is larger, so the speed of the planet will be lesser. No? So when the planet is at this point very near to the sun, so therefore he will be having the speed is maximum. No? Why? So this distance is very lesser onto the sun. As distance is lesser, therefore velocity will be maximum. No? Clear? So in this way, the speed of the planet as it revolving around the sun, so it will be changes as per the distance. So what about the torque here now? Therefore the torque experienced by this sun, torque experienced by the planet, it will be always, it will be equal to 0. Why it will be 0? So this is your force onto this one, right? And this it will be your distance here now. Distance r, theta it will be equal to 180 degree. So torque is equals to r into f into sine 180. Therefore it will be 0. Therefore there is no torque is acting on this planet, no. So therefore the angular momentum will be conserved, right? So if you want to calculate angular momentum, only two formulas are there. What is the two formulas? No, L is equals to I omega, L is equals to therefore r cross P, therefore that is nothing but a momentum into perpendicular distance. Perpendicular distance, right? So these are the formulas, no? And sometimes they may ask you torque is equals to dl by dt. These are the more maximum formulas, no? So you can use it so that you can able to solve any type of problem. So based on the angular momentum now, right? So we'll do some questions on to this one, no? Angular momentum questions, no? We'll be discussing now, right? Let us see one question, no? Right. Let us do the different type of questions, no, on this angular momentum now, right? So most important, you have to remember the direction, right hand thumb rule, no, you have to follow it, right? Let us see one question here now. So there is one particle is there, it is moving parallel to the x-axis now, right? So parallel to the x-axis, so we want to calculate the angular momentum, so about the origin now. Therefore, what we studied now, angular momentum, it will be equal to momentum into perpendicular distance. Clear? So what is the perpendicular distance here now? Momentum, what is the formula here now? You got it now? Therefore, momentum it will be nothing but a mv. We got it? So here momentum is mv into perpendicular distance. Perpendicular distance is how much now? This is a d will be a perpendicular distance here, no? So that is a d is nothing, it is not nothing, d. So that is here, okay? In the options is given as b, this should be the b. So it is b right? So what will be the direction here now? Therefore, here this is your x-axis, this is your y-axis. So this side is a momentum. Therefore, this side it will be your position vector, no, like this. It's a perpendicular to this. It is into the sun. No? Clear? So therefore, it will be along the k cap. No? Therefore, k cap no minus k cap, right? So this is x-axis, y-axis, and z-axis. It is inside no minus k cap. No. So MVB minus k cap. No. So second option will be your correct answer in this one now. Clear? Now let us do one more question here. No. So now here a unit mass is there in this question. No. In this question, therefore a unit mass is there. That means mass is equals to 1 kg. Clear? So having the position vector, there is a position vector is given, moving with a velocity is given. What is an angular momentum about the origin? No? So angular momentum is nothing but a r cross p. So just you can rewrite it as no. So p, therefore what you can write? No, p is nothing but a mv. So therefore m is nothing but a 1 kg, p is nothing but a 5y minus 6j. Clear? So therefore r cross p, you can do the cross product of this one. No? How to do the cross product now? R vector first you have to write it now, because r is given, r vector, that is I, j, k. So r vector it is given, no? Therefore it will be 3, 4. So k cap is not there, no? Therefore taken as 0. Now therefore here p, so momentum is given, no? 5y minus 6j, therefore 5 minus 6, 0. So this is right our cross product. No? How to do this one now? Therefore you can take it as I. This is minus j. Why? Because cofactors. No, this is plus. This is plus. Now, clear? So what you have to do? You have to close this one. No? So close this and close this. No, AD minus BC 0. So you again you can take this one. No? Again close this AD minus BC. Therefore it is 0 onto this. Clear? So therefore k cap you have to write. You need to write it. No, k is nothing but AD minus BC. AD means how much now? 3 into 6, no, therefore minus 18, AD minus BC minus, therefore it will be 20. So how much now? It will be minus 38 k cap now. So angular momentum is how much now? Minus 38 k cap. 38 along the z axis. This it will be your answer onto this. Clear? So in this way you can write it as, so basic questions. No, let us see. Now here also similar type of question. No. So same type of question. So right, if you want to just you can try this. So exactly how we did this question. No? Same way. Therefore L is equals to R cross P. Just be careful onto this one. No? R is how much now? Again therefore I, J, K is given. So R vector is given 1, 2, minus 1. Momentum vector it is given now. Therefore 3, 4. Therefore minus 2. Therefore I you need to close it now. Therefore AD minus BC 2 into minus 2, that is nothing but minus 4. 4 into minus 1, therefore plus 4. This is minus j. So this close it now. So minus 2. This is plus 3. Clear? This k plus k. So AD minus BC 4 minus 6. This it will be 0, therefore 0 I cap, therefore I term is not there, right? This is 1 minus j cap, no, minus j cap, therefore here minus 2 k cap now, therefore L I got it now. But what if we want to calculate now? So he is asking that angular momentum is perpendicular to, therefore perpendicularity condition means what? You have to do the dot product now. So here j is there, k is there, no, but I is not there, no. So L dot I cap means x axis, no. You can take it as minus j minus 2k dot I cap, no. Therefore I dot j, therefore 0. So k dot I also it will be 0. Entire thing it will be the 0. So L is perpendicular to I. I means x axis. Clear? So therefore it is perpendicular to x axis. Clear? In this way you can solve the problems, no. So one more, let us see here, no. Okay, Carefully try to observe this one. No? Therefore, here is given, there are 3 particles are given. Therefore, A, B, C particles are given. Calculate the angular momentum of the third particle C, so that angular momentum of the system about O is becomes to the 0. That means we have to calculate the angular momentum of this C particle, so that it should be able to right, it should be what will happen now, it should be able to, angular momentum will become to the 0, right. So here this one particle is there, this is 2 kg, so 2 kg it is there now, therefore here 2 kg it is going now. So we want to calculate the angular momentum of these 3 particles now, so therefore here what is the mass of this particle, mass it did not given, okay, right. We will see this 2 kg is there now, this is having 2 meters. So how it will be moving now, 2 kg, so it is moving with 10 meters per second, right, 10 meters per second now. So how it is going now, therefore it is having momentum. So you can use perpendicular axis theorem, right hand thumb rule no, therefore like this, it is into this one now. Into means what, x and y minus k cap. So for particle A, angular momentum for particle A, but angular momentum for particle B, angular momentum for particle C, it is given as 0. Clear? So angular momentum of particle A is how much now? Therefore 2 into 10, therefore 20 into perpendicular distance is 2 meters. Therefore 20 into 2, but it is going along the z axis now. Therefore minus k cap plus angular momentum of the B we want to calculate. So sorry, angular momentum of the C we want to calculate. So angular momentum of the B, what is given now? It is going like this here, right hand thumb rule now. Therefore it is going like this, so it is coming out. Therefore how much distance now? It is 2 kg moving 12 meters at 5 meter distance now. Therefore here 2 into 12, therefore 24 into therefore 5. So it is outward onto this one no. Therefore plus k cap no, plus angular momentum of the C, it should be equal to 0. Clear? So here how much now? It will be 40, therefore minus k cap plus, therefore so 20, 20 means 2, so 5, 10, 12, 120 k cap no, positive k plus k cap no, plus LC, it will be equal to 0. How much it will be? So 40 minus 40 plus 120 is nothing but so plus 80 k cap plus angular momentum of the C, it will be equal to 0. Angular momentum of the C particle minus 80 k cap. Minus 80 k cap. Option 2 will be your correct answer now. Clear? So in this way we can do one more question now. Let us see. Right. Let us see here no, a particle of mass 5 units, that means mass is equals to, it is given as 5 kg. Clear? So it is moving with the speed. What is the speed now? Speed is equals to 3 root 2. So therefore meters per second now. Moving in the xy plane, so which is going in this equation now. So we want to calculate magnitude of your angular momentum. So first it is going in the y is equals to x plus 4. We can write down this equation now. This is your x axis and this is your y axis. How it is going now? Therefore if x is equals to 0, therefore y is equals to x plus 4. This is given now. If x is equals to 0, y is equals to 4, that means it is 4, right? If y is equals to 0, therefore x will be equal to minus 4. Minus 4 it will be. Therefore here it will be the minus 4. If you draw this one no, right, we will see here one straight line no. Right. So in this way the particle is going with this speed now, right? So it is having this momentum. We want to calculate angular momentum about the origin no. We should know the perpendicular distance. What is the perpendicular distance here now? this should be your perpendicular distance r. But here this distance is 4, this distance is also 4, that means exactly 4 and 4, no, this is 90 degree, we are dividing exactly in the midpoint of this one, no, this is about 45 degree. Now this distance is 4, this distance is nothing but r, we can rewrite it as here adjacent side hypotenuse, no, therefore cos 45 adjacent side by therefore hypotenuse, no, therefore 45 is nothing but 1 by root 2, r is equals to 4 by root 2, therefore meters. All are clear? So we got the perpendicular distance now. So now we want to calculate magnitude of your angular momentum. So what is the angular momentum formula here now? Right? L is equals to mvr. M is how much now? 5 kg. That is L is equals to m into v into r. So 5 kg into 3 root 2 into r value is nothing but 4 by root 2. Get cancel out, no? So 15 into 4, therefore 60 kg. Now. Clear? So now let us go for one more question here, no? Right. A ring of mass, therefore there is a ring is given, no? This is one ring. So what is the mass now? It is 15 kg. Right? So diameter it will be equal to how much now? Diameter, that is nothing but a radius is nothing but a 0.1 meters. Diameter is here. He is rotating about geometrical axis with 18 therefore, right, it is rotating with a how much now? 1800 rotation per minute, that means rpm. So rpm is nothing but a frequency, not omega, right? So we will write down rps now, 1800 divided by 60 hertz. This is 0. So 6 3 is 18, therefore 30 hertz. What is omega? Omega is nothing but 2 pi into f. So 2 pi into 30, therefore 60 pi radian per second. This is your omega. So he is asking moment of inertia, its moment of inertia, angular momentum. We want to calculate both of these one. No? What is the moment of inertia? Moment of inertia of the ring, that is nothing but a mr square. Clear? What is the mass of this one now? 15 into, this is 10 to the power of minus 1 whole square, therefore 15 into 10 to the power of minus 2 kg meter square. 15 into 10 to the power of minus 2 means what you can write it now? 0.15 kg meter square, 0.15. So these are the two options are there. So 3 and 4 kg meter square. So we want to calculate angular momentum, no? So it is rotating, angular momentum will be there. This third one will be our answer, no? Because angular momentum cannot be 0 here, no? Because it is rotating now. So what will be the angular momentum, no? Therefore I omega, moment of inertia you got it, no? 0.15 into 60 into pi. So therefore you will get it as like a 28.26 joules second. No? So this it will be your correct answer, third answer, no? Third option will be your correct answer. Clear? Now, so here it is given for an object in rotational motion, angular momentum is increased from, okay, this one to this one in 30 minutes. So average torque, what we written now, torque is equals to final angular momentum minus initial angular momentum by time. Final angular momentum is how much now? 19 minus therefore 7 divided by 30. How much it will be now? Therefore 19 minus 7 means is nothing but 12 divided by 30. Therefore 3 tens are 3 fours are, that is nothing but 0.4 Newton into meter. So 0.4 Newton into meter will be your correct answer. Clear? Now, so we will go for one more concept now. Right. A uniform solid disk is there. There is one disk is there, no? So of mass is 3 kg and radius is 0.2 meters. rotate about fixed axis perpendicular to its face now with an angular frequency of 6 radians per second. Magnitude of angular momentum of the disc. Okay, what are given here now? There is a disc is there, disc, right? So its mass is about 3 kg, radius is about 0.2 meters, right? So with a omega is how much now? 6 radians per second. Clear? The magnitude of angular momentum of the disc, an axis of rotation passing through midpoint between the center and the rim. That means this is one disc is there. This is one disc, no? This is your center, no? Right? So therefore this is a rim, no? Right? So he is asking what will be the angular momentum. So when he is rotating, axis is rotating at the midpoint of this. That means what is the distance here now? That is nothing but a r by 2. Clear? So here we have to calculate what is the angular momentum. Therefore this, moment of inertia, that is Ig. So Ig, it is a disc now. Therefore mr square by 2. Therefore parallel axis theorem, we can rewrite it as I is equals to Ig, right? So m into, therefore m d square, no? So this parallel axis theorem I already did in part 2 of system of particle moment of inertia. Please, if you did not go through it, go through that moment of inertia. So theorems, no, in the parallel axis theorem already we discussed. So here I is E is equals to, that is nothing but a mr square by 2 plus therefore m into, so therefore d square, d is nothing but a r by 2 whole square. How much it will be? Mr square by 4. So mr square by 2 plus therefore mr square by 4 multiply with 2 plus 1 no, therefore 3 mr square by 4. This is your moment of inertia. So but angular momentum is asking now. What is our angular momentum now? Angular momentum is nothing but I omega. I got it, no? Therefore 3 by 4 mr square into omega. Omega is nothing but 6. So you can rewrite it as 3 by 4. Mass is how much now? 3 into r value is how much now? 0.2. That means 2 by 10. So that means 2 by 10 whole square means how much now? Therefore 4 by 100 it is into 6. Clear? So therefore 4 cancel here, no? So 6 18. So 3 3 is a 9, 9 6 is a 54. 54 by 100, 0.54. So kg meter per second. 0.54, sorry, kg meter square by second onto this. Clear? Right? So we'll do one more question here now. Right. So a disc of mass, therefore 1 kg and radius is 0.1 meter is rotating with an angular velocity, and angular velocity if the mass of 0.5 kg is put on the circumference of the disc now, right? So here there is one disc is there, this is one disc, clear? This one disc is there. So disc mass is capital M, so therefore disc mass is capital M, no? Therefore it is 1 kg. Here what we are going to do now, we are going to keep one small amount of mass here now, that is nothing but 0.5 kg on this one. So initially it was rotating, therefore here what you are doing now, therefore suppose initially we are rotating now, therefore with an angular velocity it is having I 1 omega 1. So later on what we are did now, therefore we are keeping one, so this is your I dash, therefore I 2, and here there is one mass is there, therefore and due to this one now omega 2. So you can use conservation of angular momentum now, therefore I 1 omega 1 is equals to I 2 omega 2. Clear? So first let us write down I 1. What is I 1 here now? I 1, it is a disc now, therefore mr square by 2. Clear? So therefore I 1 is how much now? Mr square by 2 into angular velocity is written now. So therefore 20 radians per second now, 20 is equals to I 2. Therefore I 2 is what? It is rotating the disc now, plus and that mass is also getting rotated onto this one now. But here mass of the disc is 1 kg, but we kept the mass is nothing but m by 2, you can write it now. Therefore, mr square by 2 plus therefore m by 2 into r square. Clear? Therefore, here this particle will be rotating mr square. Clear? So, into omega 2 we want to calculate it now. So, how much it will be? Now, therefore, here, so mr square by 2 into 20, it will be equal to mr square into omega 2, therefore, mr square get cancelled, therefore, 2 omega 2 it will be equal to 10, so radians per second, right. So, here why? Because some mass is added, gently it is added, no. So, therefore, what will happen now? Therefore, it is going to rotate with a slowly onto this. Clear? So, this is one of your another question onto this. And one more question, no? Right. One more important question, no? So, here a particle of mass m is there. So, this is one particle is there, it is mass is m. It is having momentum, no? Therefore, perpendicular to the uniform, this is d. Right. It is hinged at the center now. Therefore, it will be able to hinged at the center, can freely rotate in a horizontal plane, horizontal, therefore, like this now. So, here one particle is coming and hitting onto this, right. So, it is a fixed axis onto this one, no? Hinged is frictionless, the particle sticks and to this one, no? The angular velocity, angular speed of just after the collision, no? Just after the collision, be careful now. So, here a particle is there. This is one particle, right. So, it is moving with this one, no. This is having m, this total rod is there, no. Therefore, this mass is about 6 m. Clear? So, this particle is coming and hitting onto this one, no. So, of this rod, right. Therefore, like this one rod is there, no. Therefore, here the particle is coming and hitting onto this, it is getting stick to this. Therefore, what will happen now? This is rotating onto this. We want to calculate the angular momentum of this rod onto this. So, here, so initial angular momentum. What is the initial angular momentum now? Initial angular momentum is, so this rod is not rotating now, only this particle is moving. So, it is having momentum, that is mv into this distance is how much now? Therefore, d by 2, this is your distance, right, perpendicular distance. Now, final angular momentum now. So, finally what will happen now? This particle is getting stick and this rod is also rotating. So, we can rewrite it as like a I omega. So, what is the moment of inertia? This rod is rotating, rod mass is how much now? 6 m. So, 6 m into d square by 12. Therefore, ml, see rod moment of inertia of the rod is how much now? That is nothing but a ml square by 12. So, this is your rod moment of inertia. Therefore, plus, clear. So, this particle is going and sticking to this one, no? So, this particle is also rotating onto this. So, this is m into d by 2 whole square, clear, into omega. Therefore, how much now? This is 2. So, m d square by 2 plus m d square by 4 into omega. So, it will be 2 plus 1, therefore, 2 multiplied, no, 4 it will be there, 2 plus 1, 3 m d square by 4 into omega. This is your final angular momentum. Initial angular momentum and final angular momentum will be equal. Therefore, mv into d by 2, it will be equal to 3m into d square by 4 into omega. Therefore, this m and m get cancelled out. So, this one d also get cancelled out, this 2 also get cancelled out, no. So, therefore, omega, this is 2. So, 2v by 3d will be your answer, 2v by 3d. So, this it will be your first option will be your correct answer now. Clear? So, one more. Now, we will see. Right. So, there is a one ballet dancers is there. Ballet dancers means what they will do? They will do skating and they will be able to rotate. So, ballet dancer is there dancing on a smooth floor and spinning in the vertical axis with our arms folded. So, arms are folded here like this. So, therefore, it is an angular velocity. Therefore, this one ballet dancer is there So here arms are folded here, no? Therefore she is rotating. Therefore with a angular velocity is how much, no? 20 radians per second. Right? So when he stretches her arms fully, the spinning speed decreases. Therefore what will happen now? Now she is changing her speed here. Now, therefore she is stretching now. Omega 2, it will becomes like a 10 radians per second. So if initially moment of inertia is I, the new moment of inertia, therefore I2 we want to calculate it now. Simple. Again stretching and folding, no? So what it will do now? We can see law of conservation of angular momentum, no? Initial angular momentum I1 omega 1 is equals to I2 omega 2. I1 is how much now? I into 20 is equals to I2 into 10. So therefore I2 is equals to, so therefore 2I. So when it stretches, no, moment of inertia will be increased. So therefore it will be 2I will be your answer now. 2I. Clear? So can you tell me here we can add one question now. What about the kinetic energy? So what about the kinetic energy? Initial kinetic energy of this one is how much now? Initial kinetic energy, so 1 by 2 into I into 20 square. Clear? So therefore here how much now? 20 square is 400 divided by 2, 200 I. So joules will be your initial kinetic energy now. So what happened to the final kinetic energy? So what happened to the final kinetic energy? See, we can see difference onto this one. No? What will be the final kinetic energy? Final kinetic energy, it will be equal to 1 by 2 into I is how much, no? Therefore it will become like a 2I into 10 square. So therefore it is 100. So 100 I joules. What happened now? Here initial kinetic energy is 200 I. Final kinetic energy is nothing but 100 I. So what happened to the remaining other energy now? Right? If you really know this question, know this answer, no? Just please comment it, no? Therefore, what happened to the kinetic energy? Initially this much is there, no? So therefore, then afterwards what happened now? Kinetic energy is changed. What happened to this kinetic energy? Where it is gone now? So therefore, this energy was taken by the body, therefore to stretch the hands, no? So that energy was utilized by this one. So here angular momentum is, it will be constant, no, but kinetic energy it will be the changing onto this, right? So this point also you should remember in the conservation of your angular momentum now, right? So here there is one thin and circular disc is there of mass m and radius is r, rotating in a horizontal plane about an axis passing through its center and perpendicular to its plane and with an angular velocity is omega. If another disc of same dimension but mass is how much, no? Mass is nothing but m by 4 placed gently on the first disc, no, coaxially, the new angular velocity. So here what happened now? What is this question now? Here initially there is a disc is there now. This disc is no, this disc is rotating. So its mass is how much now? It is m and radius is r. Right? So initial angular momentum is how much now? Therefore disc, no, therefore mr square by 2, right? So then it is rotating with an angular velocities, therefore it is rotating with an angular velocities omega. Therefore omega 1 it will be equal to omega. Now what we are going to do now? We are going to add, so one more small disc now, therefore one more small disc here, no. So mass is m by 4, therefore what will be the new angular velocity now? So initially what happened now? Initial angular velocity, moment of inertia and angular velocity. So final one now, it should be the same. So initial one is how much now? First one is mr square by 2 into omega. But finally, so not only this one disc, no, two discs are there. Two discs, no, they are kept on it, right? Same axis. First disc to rotate, no, mr square by 2 plus second disc is kept, no. Therefore same dimension. See, same dimensions is there, no. So m by 4 into, therefore r square, so by 2, right? So by 2, therefore into omega dash. So how much it will be? Now here mr square by 2 into omega. So here you can rewrite it as by 4, no, 4 right, it is 4, no, 4 plus 1, therefore 5 mr square by therefore 8 into omega dash. Therefore mr square get cancelled out, no, so this is 4, so omega dash it will be equal to 4 by 5 omega. So 4 by 5 omega, this it will be your answer on this. Clear? Right? So some more questions, no, right, some more questions, no, we can rewrite it as. So here some more problems, no, we can do it, no. So let us see, there is a one disc, one ring is there, no, this is one ring, so is rotating now. So therefore it is having moment of inertia is how much, no, mr square. So it is rotating with an angular velocity is omega. Suppose here gently we are going to keep the two masses here, no, two small masses m, two small masses m now. So this capital M is capital M, this mass is nothing but a capital M, right. These two masses, no, gently kept onto this. When it's kept gently, therefore it is angular velocity is changed onto this. We want to calculate, so change in angular velocity. Therefore again you can write down I1 omega 1 is equals to I2 omega 2. So I1 is how much now, therefore mr square into, so into omega, but I2, so ring is rotating, this is ring, no. So rotating of the ring, capital M into r square plus two masses are there, therefore 2m into r square into omega dash will be your conservation of angular momentum. R square taken common, cancel it, no. So this is omega dash, it can be written as m by, so capital M plus 2m into omega will be your final angular velocity. Clear? Now one more question, no, we can rewrite it as, no, suppose our earth is there, no, this is our earth. So our earth is there, no, therefore this is our earth, no. One more question, suppose our earth is there, what is happening now, this earth, no, our earth is rotating with an angular velocity. What is an angular velocity? Therefore 2 pi by time period means nothing but 24 hours, this is 24 hours now, right. So that is nothing but 2 pi by 24 hours radian per hour. Clear? Clear? Now what happened now, this is rotating. So suddenly what we are going to do now, we are going to that suddenly, therefore what happened to the earth now, therefore it is compressed. So therefore its size becomes like a smaller onto this one now, right. So therefore here this radius, what will happen now, this is radius is having r now. So therefore here it is having moment of inertia. Sphere, what is a sphere now, solid sphere now, solid sphere is nothing but 2 by 5 mr square, right. So what happened to the now, therefore we are making, therefore this radius is become like a half of this one. Mass is not changing anything, so it is compressed. Therefore what will be the new day, new time period, or the day, duration of the day, we can write it now. So therefore here new moment of inertia, what will happen now, new moment of inertia I is equals to m 2 by 5, therefore here it will be 2 by 5 m into r by 2 whole square. So what will happen now, 2 by 5 m into r square by 4, right. So this is your new moment of inertia. So what we can write it now, we can rewrite it as again the same thing. So therefore here I1 omega 1 is equals to I2 omega 2. I1 is how much now, 2 by 5 mr square into omega is nothing but 2 pi by t, 24 hours, no. So this is 24 hours, okay, we can rewrite it as 24 hours, no. It will be equal to, therefore I dash, therefore I2 is nothing but 2 by 5 into mr square by 4 into 2 pi by t, new day. So 2 by 5 mr square, 2 by 5 mr square, 2 pi and 2 pi get cancelled out, no. So what you will get it now here, so therefore here 4t it will be equal to 24. So t is equals to 24 divided by 4. So therefore it will be 2. So therefore it is 2. Therefore what will happen now? It will become like a 6 hours per day. Suppose if our earth is there, no, it is become like a shrink to the, so half of its radius, no. Therefore So the new day it will be having our only 6 hours. Within the 6 hours, no, we will be completing our day now. Clear? So now, right? So we can we'll see some more questions now in the rotational motion. So we'll do like one separate video based on the questions onto this. So these are the possible questions now for NEET level and JEE mains level for calculation of our angular momentum now, right? Go through it now thoroughly. So thank you. Please subscribe to my channel. Thank you for watching my video.